CIET NCERT presents audiobook Ganit Prakash, textbook of mathematics for grade 7.
Chapter number 3, A Peak Beyond the Point. Page number 46. On the right side of the page, there is a QR code, scanning which you can reach out to the additional resources to this chapter. 3.1 The Need for Smaller Units. Sonu's mother was fixing a toy. She was trying to join two pieces with the help of a screw. Sonu was watching his mother with great curiosity. His mother was unable to join the pieces. Sonu asked why. His mother said that the screw was not of the right size. She brought another screw from the box and was able to fix the toy. The two screws looked the same to Sonu. But when he observed them closely, he saw they were of slightly different lengths. Sonu was fascinated by how such a small difference in lengths could matter so much. He was curious to know the difference in lengths. He was also curious to know how little the difference was because the screws looked nearly the same. In the above picture, screws are placed above a scale. Measure them and write their length in the space provided. On this page, you find pictures of Sonu and his mother. In the next picture, Sonu is watching the toy. Page number 47. On this page, you find 6 different pictures of scale with screws placed on them. In the first one, the screw is displaying the measure between 2 centimeters and 3 centimeters. In the next picture, the length of the screw is showing more than 2.5 centimeters but less than 3 centimeters. In the third picture, the length of the screw is 2 whole 7 upon 10 centimeters. In the other 3 pictures, you need to see the length of the screw and write down in the blanks. Which screw helped you measure the length of the screw accurately? Why? What is the meaning of 2 whole 7 upon 10 centimeters? The length of the first screw. As seen on the ruler, the unit length between two consecutive numbers is divided into 10 equal parts. To get the length 2 whole 7 upon 10 centimeters, we go from 0 to 2 and then take 7 parts of 1 upon 10. The length of the screw is 2 centimeters and 7 upon 10 centimeters. Similarly, we can make sense of the length 3 whole 2 upon 10 centimeters. We read 2 whole 7 upon 10 centimeters as 2 and 7/10 centimeters and 3 whole 2 upon 10 centimeters as 3 and 2/10 centimeters. Can you explain why the unit was divided into smaller parts to measure the screws? Measure the following objects using a scale and write their measurements in centimeters as displayed earlier for the lengths of the screws. Pen, sharpener, and any other object of your choice. Write the measurements of the objects displayed in the picture. Page number 48. Here we have 3 different pictures of objects with scale. First one is an eraser placed above the scale and the length is displayed between 2 and 4/10 centimeters. In the next picture, we have a scale and a pencil placed above it, and the length of the pencil is displayed between 4 and 5/10 centimeters. In the third picture, we have another object displaying 1 and 4/10 centimeters. As observed here, when exact measures are required, we can make use of smaller units of measurement. 3.2 A tenth part. The length of the pencil displayed in the figure below is 3 whole 4/10 units, which can be read as 3 units and 4 1/10ths. That is 3 into 1 plus 4 into 1/10 units. Here we have two pictures in which the length of the pencil is displaying the length as 3 whole 4/10. And in the next picture, we have the length of the pencil as 3 whole 4/10. The length between 0 and 1 has been divided into 10 equal parts, displaying 1/10 plus 1/10 plus 1/10 10 times. That is equal to 10 times 1/10, that is equal to 10 into 1/10, that is equal to 1 unit. This length is the same as 34 1/10 units because 10 1/10 units make 1 unit. Page number 49. 34 into 1/10 is equal to 34/10, that is equal to 10/10 plus 10/10 plus 10/10 plus 4/10. That is 34 1/10. That is equal to 1 plus 1 plus 1 plus 4/10. 3 and 4 1/10. A few numbers with fractional units are displayed below along with how to read them. 4 whole 1/10 can be read as 4 and 1/10. 4/10 can be read as 4 1/10 or 4/10. 41/10 can be read as 41 1/10 or 41/10. 41 whole 1/10 can be read as 41 and 1/10. For the objects displayed below, write their lengths in two ways and read them aloud. An example is given for the USB cable. Note that the unit length used in each diagram is not the same. The length of the USB cable is 4 and 8/10 units or 48/10 units. Here in the picture, we have a scale on which USB cable is placed and it displays 48/10 units as the length. In another picture, the length of the smallest finger of the hand, you are supposed to measure the length, which is displaying the length as 1 and 3/10 units or 13/10 units. In the third picture, we have a lunchbox. The height of the lunchbox is displaying as 28/10 units. And in the fourth, we have a leaf placed on the scale. The length of the leaf is 10 whole 9/10 units, or we can read it as 109/10 units. Arrange these lengths in increasing order. A 9/10, B 1 whole 7 upon 10, C. 130 upon 10, D. 13 whole 1 upon 10, E. 10 whole 5 upon 10, F. 7 whole 6 upon 10, G. 6 whole 7 upon 10, H. 4 upon 10. Page number 50. Arrange the following lengths in increasing order. 4 whole 1 upon 10, comma, 4 upon 10, comma, 41 upon 10, comma, 41 whole 1 upon 10. Sonu is measuring some of his body parts. The length of Sonu's lower arm is 2 whole 7 upon 10 units and that of his upper arm is 3 whole 6 upon 10 units. What is the total length of his arm? To get the total length, let us see the lower and upper arm length as 2 units and 7 1/10ths and 3 units and 6 1/10ths respectively. So, there are 2 plus 3 units and 7 plus 6 1/10ths. Together, they make 5 units and 13 1/10ths. But 13 1/10ths is 1 unit and 3 1/10ths. So, the total length is 6 units and 3 1/10ths, which is displayed here as 2 plus 3 plus 7 upon 10 plus 6 upon 10, that is equal to 2 plus 3 plus 13 upon 10, that is equal to 5 plus 13 upon 10, that is equal to 5 plus 10 upon 10 plus 3 upon 10, that is equal to 5 plus 1 plus 3 upon 10, that is equal to 6 plus 3 upon 10, that is equal to 6 whole 3 upon 10. B. 2 whole 7 upon 10 plus 3 whole 6 upon 10 is added as 5 whole 13 upon 10, which can be expressed as 6 whole 3 upon 10, or both the lengths can be converted to tenths and then added. C. 27 1/10ths and 35 1/10ths is 62 1/10ths. 27 upon 10 plus 35 upon 10 is equal to 62 upon 10. 62 upon 10 is the same as 60 1/10ths, that is 60 upon 10, and 2 1/10ths, that is 2 upon 10, which is equal to 6 units and 2 1/10ths, that is 6 whole 2 upon 10. Page number 51. The lengths of the body parts of a honeybee are given. Find its total length. There is a picture of a honeybee which is displaying its head, thorax and abdomen separately. The measurement of head is 2 whole 3 upon 10 units, thorax 5 whole 4 upon 10 units, abdomen 7 whole 5 upon 10 units. The length of Shailja's hand is 12 whole 4 upon 10 units and her palm is 6 whole 7 upon 10 units as displayed in the picture. What is the length of the longest, that is middle finger? The length of the finger can be found by evaluating 12 plus 4 upon 10 within brackets minus 6 plus 7 upon 10 within brackets. This can be done in different ways. For example, A. 12 plus 4 upon 10 minus 6 minus 7 upon 10. That is equal to 12 minus 6 within brackets plus 4 upon 10 minus 7 upon 10 within brackets. That is equal to 6 minus 3 upon 10. That is equal to 5 plus 1 minus 3 upon 10. That is equal to 5 plus 10 upon 10 minus 3 upon 10. That is equal to 5 plus 7 upon 10. That is equal to 5 whole 7 upon 10. On the right side of the page, there is a picture of the hand of Shailaja, which is showing the length of the hand as 12 whole 4 upon 10 units and the length of the palm as 6 whole 7 upon 10 units. B. 12 whole 4 upon 10 minus 6 whole 7 upon 10 can be solved as 11 whole 14 upon 10 minus 6 whole 7 upon 10, that is equal to 5 whole 7 upon 10. As in the case of counting numbers, it is convenient to start subtraction from the tenths. We cannot remove 7 1/10ths from 4 1/10ths. Page number 52. So we split a unit from 12 and convert it to 10 1/10ths. Now the number has 11 units and 14 1/10ths. We subtract 7 1/10ths from 14 1/10ths and then subtract 6 units from 11 units. Try computing the difference by converting both lengths to tenths. A celestial pearl Danio's length is 2 whole 4 upon 10 centimeters and the length of a Philippine goby is 9 upon 10 centimeters. What is the difference in their lengths? How big are these fish compared to your finger? We find beautiful pictures of celestial pearl Danio fish and Philippine goby fish on this page. Observe the given sequence of numbers. Identify the change after each term and extend the pattern. A. 4, 4 whole 3 upon 10, 4 whole 6 upon 10, and we have 4 blanks in front of them. B. 8 whole 2 upon 10, 8 whole 7 upon 10, 9 whole 2 upon 10, and 4 blanks in front of them to be filled. C. 7 whole 6 upon 10, 8 whole 7 upon 10, 4 blanks in front of these. D. 5 whole 7 upon 10, 5 whole 3 upon 10, and 4 blanks. E. 13 whole 5 upon 10, 13, 12 whole 5 upon 10, 4 blanks in front of them. F. 11 whole 5 upon 10, 10 whole 4 upon 10, 9 whole 3 upon 10 and 4 blanks in front of these. 3.3 100th part. The length of a sheet of paper was 8 whole 9 upon 10 units, which can also be said as 8 units and 9 1/10ths. It is folded in half along its length. What is its length now? There is a picture provided of a scale and a folded paper which is placed above it. Page number 53. We can say that its length is between 4 whole 4 upon 10 units and 4 whole 5 upon 10 units. But we cannot state its exact measurement since there are no markings. Earlier, we split a unit into 10 1/10ths to measure smaller lengths. We can do something similar and split each 1/10th into 10 parts. On the right side of the page, we are provided 3 different pictures of the scale and the folded paper, in which we find there are markings explained with each unit divided into 10 equal parts. The length between 4 and 5 is divided again into 10 equal parts. The length between 4 and 5 is displayed such that each 1/10th has 10 smaller parts. What is the length of this smaller part? How many such smaller parts make a unit length? As displayed in the figure, each 1/10th has 10 smaller parts and there are 10 1/10ths in a unit. Therefore, there will be 100 smaller parts in a unit. Therefore, one part's length will be 1 upon 100 of a unit. Here we have one more picture in which the length between 4 and 5 has been divided into 10 equal parts, displaying 4 1 upon 10, 4 2 upon 10, 4 3 upon 10, 4 4 upon 10, 4 5 upon 10, 4 6 upon 10, 4 7 upon 10, 4 8 upon 10 and 4 9 upon 10. Returning to our question, what is the length of the folded paper? We can see that it ends at 4 whole 4 upon 10, 5 upon 100, read as 4 units and 4 1/10ths and 5 1/100ths. How many 1/100ths make 1/10th? Can we also say that the length is 4 units and 45 1/100ths? Page number 54. Observe the figure given here. Notice the markings and the corresponding lengths written in the boxes when measured from 0. Fill in the lengths in the empty boxes. We have measurements displayed here with the boxes in which you are required to fill up the measurements. The length of the wire in the first picture is given in 3 different ways. Can you observe how they denote the same length? In the next picture, we have a ruler and an object placed over it, that is wire, and the measurements are displayed as 0, 1 upon 10, 2 upon 10, 3 upon 10, 4 upon 10, 5 upon 10, 6 upon 10, 7 upon 10, 8 upon 10, 9 upon 10, 1 whole 1 upon 10 and 1 whole 2 upon 10. The length of the wire is 1 whole 1 upon 10 and 4 upon 100. 1 whole 1 upon 10, 4 upon 100. 1 and 1/10th and 4 hundredths. 1 whole 14 upon 100, 1 and 14 hundredths. 114 upon 100, 100 and 14 hundredths. For the lengths given here, write the measurements and read out the measures in words. We have a scale with a wire placed above it. You have to read the measure of the wire with the help of scale. There is another picture which is given here. You have to read the measurements and write page number 55. We have 2 different pictures with the markings on the scale and the wire is placed above them. You are supposed to read and write the measurements. In each group, identify the longest and the shortest lengths. Mark each length on the scale. A 3 upon 10, 3 upon 100, 33 upon 100. On a scale, the length between 0 and 1 has been divided equally into 10 parts. Each part again has been divided into 10 equal parts. B 3 whole 1 upon 10, 30 upon 10, 1 whole 3 upon 10. Here in the picture, on a scale, there are 10 units marked from 0 to 10, with each unit divided into 10 equal parts. C 45 upon 100, 54 upon 100, 5 upon 10, 4 upon 10. Here in the picture, on a scale, there are 10 units marked between 0 and 1, and each unit is again divided into 10 equal parts. D 3 whole 6 upon 10, 3 whole 6 upon 100, 3 whole 6 upon 10, 6 upon 100. In this picture, there are 10 markings on a scale between 30 upon 10 and 40 upon 10. Page number 56. E 8 upon 10, 2 upon 100, 9 upon 100, 1 whole 8 upon 100. The scale has 10 units between 0 and 1, and each unit further has been divided into 10 equal parts, which is given in the picture. F 7 whole 3 upon 10, 5 upon 100, 7 whole 5 upon 10, 7 whole 41 upon 100. In this picture, we have a scale. On the scale, the marking starts with 68 upon 10 and has 10 equal parts. G 65 upon 10, 15 upon 100, 5 whole 87 upon 100, 5 whole 7 upon 100. Here in the picture, we have a scale. We find 10 equal units with 6 and 64 upon 10 marked, and each unit has been divided into 10 equal subparts. What will be the sum of 15 whole 3 upon 10, 4 upon 100, and 2 whole 6 upon 10, 8 upon 100? This can be solved in different ways. Some are given here. A. Method 1. Within brackets 15 plus 2 plus within brackets 3 upon 10 plus 6 upon 10 plus within brackets 4 upon 100 plus 8 upon 100. That is equal to 17 plus 9 upon 10 plus 12 upon 100. That is equal to 17 plus 9 upon 10 plus 1 upon 10 plus 2 upon 100. That is equal to 17 plus 10 upon 10 plus 2 upon 100. That is equal to 18 whole 2 upon 100. A picture is given here in which it is written 10 hundredths is the same as 1/10. B. Method 2. 15 whole 3 upon 10, 4 upon 100 plus 2 whole 6 upon 10, 8 upon 100 is added as 17 whole 9 upon 10, 12 upon 100. That is equal to 17 whole 10 upon 10, 2 upon 100. That is equal to 18 whole 2 upon 100. Page number 57. Are both these methods different? Observe the addition done below for 483 plus 268. Do you observe any similarities between the methods given here? Within brackets 400 plus 80 plus 3 plus within brackets 200 plus 60 plus 8, that is equal to within brackets 400 plus 200 plus within brackets 80 plus 60 plus within brackets 3 plus 8, that is equal to 600 plus 140 plus 11, that is equal to 600 plus 150 plus 1, that is equal to 700 plus 50 plus 1, that is equal to 751. One can also find the sum is 15 whole 3 upon 10, 4 upon 100 plus 2 whole 6 upon 10, 8 upon 100 by converting to hundreds as follows. C. Within brackets 15 plus 2 plus within brackets 34 upon 100 plus 68 upon 100, that is equal to 17 plus 102 upon 100, that is equal to 17 plus 1 plus 2 upon 100, that is equal to 18 whole 2 upon 100. In the picture, it is given 100 hundreds is same as 1 unit. D. 1534 upon 100 within brackets plus 268 upon 100 within brackets, that is equal to 1802 upon 100, that is equal to 1800 upon 100 plus 2 upon 100, that is equal to 18 whole 2 upon 100. In the picture, it is given that 15 is the same as 1500 hundreds and 2 is the same as 200 hundreds. What is the difference? 25 9 upon 10 minus 6 whole 4 upon 10 7 upon 100. One way to solve this is as follows. 25 whole 9 upon 10 minus 6 whole 4 upon 10 can be written as 25 whole 8 upon 10, 10 upon 100 minus 6 whole 4 upon 10, 7 upon 100, which again can be written as 25 whole 8 upon 10, 10 upon 100 minus 6 whole 4 upon 10, 7 upon 100. On subtracting, we get 19 whole 4 upon 10, 3 upon 100. Page number 58. Solve this by converting to hundreds. What is the difference? 15 whole 3 upon 10, 4 upon 100 minus 2 whole 6 upon 10, 8 upon 100. One way to solve this is as follows. Here, the method is explained by grouping the tens and hundreds place. On subtracting, we get 2 whole 6 upon 10, 6 upon 100. Observe the subtraction done below for 653 minus 268. Do you find any similarities with the methods given here? Within brackets 600 plus 50 plus 3 minus within brackets 200 plus 60 plus 8, that is equal to within brackets 600 minus 200 plus within brackets 50 minus 60 plus within brackets 3 minus 8. That is equal to within brackets 600 minus 200 plus within brackets 40 minus 60 plus within brackets 13 minus 8. That is equal to within brackets 600 minus 200 plus within brackets 40 minus 60 plus 5. That is equal to within brackets 500 minus 200 plus within brackets 140 minus 60 plus 5. That is equal to 300 plus 80 plus 5. That is equal to 385. Figure it out. Find the sums and differences. A. 3 upon 10 plus 3 whole 4 upon 100. B. 9 whole 5 upon 10, 7 upon 100 plus 2 whole 1 upon 10, 3 upon 100. C. 15 whole 6 upon 10, 4 upon 100 plus 14 whole 3 upon 10, 6 upon 100. D. 7 whole 7 upon 100 minus 4 upon 100. E. 8 whole 6 upon 100 minus 5 whole 3 upon 100. F. 12 whole 6 upon 100, 2 upon 100 minus 9 upon 10, 9 upon 100. 3.4 Decimal place value. You may have noticed that whenever we need to measure something more accurately, we split a part into 10 smaller equal parts. We split a unit into 10 1/10ths and then split each 1/10th into 10 1/100ths, and then we use these smaller parts to measure. Page number 59. Can we not split a unit into 4 equal parts, 5 equal parts, 8 equal parts, or any other number of equal parts instead? Yes, we can. The example here compares how the same length is represented when the unit is split into 10 equal parts and when the unit is split into 4 equal parts. If an even more precise measure is needed, each quarter can further be split into 4 equal parts. Each part then measures 1 upon 16 of a unit. That is, 16 such parts make 1 unit. Here in the figure it is given that the length of the pencil is 2 whole 5 upon 10. In the next picture, the figure gives the length of the pencil as 2 whole 2 upon 4. In the next picture, the length of the pencil is between 2 and 3, which is divided into 4 equal parts, and it reads 2 whole 3 upon 4. The length between 2 whole 3 upon 4 and 3 has been divided into 4 equal parts. Then why split a unit into 10 parts every time? The reason is the special role that 10 plays in the Indian place value system. For a whole number written in the Indian place value system, for example 281, the place value of 2 is hundredths, that of 8 is tenths, and that of 4 is 1. Each place value is 10 times bigger than the one immediately to its right. Equivalently, each place value is 10 times smaller than the one immediately to its left. 10 ones make 1 10. 10 tens make 100. 10 hundreds make 1000, and so on. Here there is a picture given with the help of boxes from right to left. We can find when 1 is multiplied by 10, we get 10, and when 10 is multiplied by 10, we get 100, and when 100 is multiplied by 10, we get 1000, and when 1000 is multiplied by 10, we get 10,000. Similarly, from left to right, when we divide 10,000 by 10, we get 1000. When 1000 is divided by 10, we get 100. When 100 is divided by 10, we get 10. And when 10 is divided by 10, we get 1. In order to extend this system of writing numbers to quantities smaller than 1, we divide 1 into 10 equal parts. What does this give? It gives 1/10. Further, dividing it into 10 parts gives 100, and so on. Page number 60. Here we have a picture given with the numbers in the boxes as 10,000, 1,000, 100, 10, 1, 1 upon 10, and 1 upon 100. From right to left, when we multiply 1 upon 100 with 10, we get 1 upon 10. When 1 upon 10 is multiplied by 10, we get 1. And when 1 is multiplied by 10, we get 10. When 10 is multiplied by 10, we get 100. When 100 is multiplied by 10, we get 1000. When 1000 is multiplied by 10, we get 10,000. Likewise, when we go from left to right and divide 10,000 by 10, we get 1000. When 1000 is divided by 10, we get 100. And when 100 is divided by 10, we get 10. When 10 is divided by 10, we get 1. When 1 is divided by 10, we get 1 upon 10. And 1 upon 10 when divided by 10, it gives us 1 upon 100. This is beautifully given in the picture. Can we extend this further? What will the fraction be when 1 upon 100 is split into 10 equal parts? It will be 1 upon 1000. That is, 1000 such parts make up a unit. Here we have a picture given in which the markings are given between 0 and 1. As 1 upon 10, 2 upon 10, 3 upon 10, 4 upon 10, 5 upon 10, 6 upon 10, 7 upon 10, 8 upon 10, 9 upon 10. Again, the markings between 6 upon 10 and 7 upon 10 have been divided into 10 equal parts as 60 upon 100, 61 upon 100, 62 upon 100, 63 upon 100, 64 upon 100, 65 upon 100, 66 upon 100, 67 upon 100, 68 upon 100, 69 upon 100, and 70 upon 100. Again, the markings between 66 upon 100 and 67 upon 100 have been subdivided into 10 equal parts as 660 upon 1000, 661 upon 1000, and so on till 669 upon 1000, with the last 670 upon 1000. Just as when we extend to the left of 10,000, we get bigger place values at each step. We can also extend to the right of 1 upon 1000, getting smaller place values at each step. Page number 61. Here we have boxes with the values given here as 1 lakh in the first box, then 10,000, then 1,000, 100, 10, 1, 1 upon 10, 1 upon 100, 1 upon 1,000, 1 upon 10,000. When we move from right to left, when we multiply 1 upon 10,000 with 10, we get 1 upon 1000. When we multiply 1 upon 1000 with 10, we get 1 upon 100. When 10 is multiplied with 1 upon 100, we get 1 upon 10. When 1 upon 10 is multiplied by 10, we get 1. When 1 is multiplied by 10, we get 10. When 10 is multiplied by 10, we get 100. When 100 is multiplied by 10, we get 1000. When 1000 is multiplied by 10, we get 10,000. And when 10,000 is multiplied by 10, we get 1 lakh. Now, moving towards the right from left side, we are dividing 1 lakh by 10, we get 10,000. On dividing 10,000 by 10, we get 1000. On dividing 1000 by 10, we get 100. 100 divided by 10, we get 10. When 10 is divided by 10, we get 1. 1 is divided by 10, we get 1 upon 10. When 1 upon 10 is divided by 10, we get 1 upon 100. When 1 upon 100 is divided by 10, we get 1 upon 1000. When 1 upon 1000 is divided by 10, we get 1 upon 10,000. This way of writing numbers is called the decimal system, since it is based on the number 10. Decem means 10 in Latin, which in turn is cognate to the Sanskrit dasha, meaning 10, with similar words for 10 occurring across many Indian languages, including Odia, Konkani, Marathi, Gujarati, Hindi, Kashmiri, Bodo, and Assamese. We shall learn about other ways of writing numbers in later grades. How big? We always know that 100 tens make 1000 and 100 hundreds make 10,000. We can ask similar questions about fractional parts. A. How many thousandths make 1 unit? B. How many thousandths make 1 tenth? C. How many thousandths make 1 hundredth? D. How many tenths make 1 ten? E. How many hundredths make 1 ten? Make a few more questions of this kind and answer them. Notation, writing and reading of numbers. We have been writing numbers in a particular way, say 456, instead of writing them as 4 into 100 within brackets 4 hundreds plus 5 into 10 within brackets 5 tenths plus 6 into 1 within brackets 6 ones. Similarly, can we skip writing tenths and hundreds? Can the quantity 4 whole 2 upon 10 be written as 42? Within brackets, skipping the 1 upon 10 in 2 into 1 upon 10? If yes, how would we know if 42 means 4 tenths and 2 units, or it means 4 units and 2 tenths? Similarly, 705 could mean A. 7 hundredths and 0 tenths and 5 ones. Within brackets 700 plus 0 plus 5. B. 7 tenths and 0 units and 5 tenths. Within brackets 70 plus 0 plus 5 upon 10. C. 7 units and 0 tenths and 5 hundredths. Within brackets 7 plus 0 upon 10 plus 5 upon 100. Page number 62. Since these are different quantities, we need to have distinct ways of writing them. To identify the place value where integers end and the fractional parts start, we use a point or period. within brackets a dot as a separator called a decimal point. The above quantities in decimal notation are then expressed in the form of a column here. We have two columns with two quantity and decimal notations represented. First one as 7 hundreds and 5 ones. Within bracket 700 plus 0 plus 5. And decimal notation for that is given here as 705. Next 7 tenths and 5 tenths. Within bracket 70 plus 0 plus 5 upon 10. And the decimal notation for the same is 70.5. Next quantity is 7 units and 5 hundredths. That is 7 plus 0 plus 5 upon 100. Decimal notation for the same is 7.05. These numbers, when shown through place value, are as follows. There are 6 columns with decimal number, hundreds, tens, units, decimal point, tens, hundreds, in which 705 is written as 7 into 100 under hundreds place, 0 into 10 under tens, 5 into 1 under units, then comes the decimal point, and tens and hundreds are blank. For 70.5, we have 7 into 10 in tens, 0 into 1 in units column, then decimal point, 5 into 1 upon 10 in tens place. Hundreds place is vacant. 7.05 is written as 7 into 1 in units place, decimal point, 0 into 1 upon 10 in tens column, and 5 into 1 upon 100 in hundredth column. Here we have another picture with boxes which is given here. We have 4 yellow boxes, decimal place, and then we have 6 green boxes, which is giving us the notion of units and tens place, and 1/10th place, 1 upon 100, that is 100th place. Page number 63. Thus, decimal notation is a natural extension of the Indian place value system to numbers also having fractional parts. Just as 705 means 7 into 100 plus 5 into 1, the number 70.5 means 7 into 10 plus 5 into 1 upon 10, and 7.05 means 7 into 1 plus 5 into 1 upon 100. We have seen how to write numbers using the decimal point, that is dot. But how do we read or say these numbers? We know that 705 is read as 705. 70.5 is read as 70.5, short for 70 and 5 tenths. 7.05 is read as 7.05, short for 7 and 5 hundredths. 0.274 is read as 0.274. We don't read it as 0.274, as 0.274 means 2 1/10ths and 7 1/100ths and 4 1/1000ths. Make a place value table similar to the one above. Write each quantity in decimal form and in terms of place value and read the number. A. 2 ones, 3 tens and 5 hundreds. B. 1 ten and 5 tens. C. 4 ones and 6 hundreds. D. 100, 1 one and 100th. E. 8 upon 100 and 9 upon 10. F. 5 upon 100. G. 1 upon 10. H. 2 whole 1 upon 100, comma, 4 whole 1 upon 10 and 7 whole 7 upon 1000. In the chapter on large numbers, we learnt how to write 23 hundreds. 23 hundreds is equal to 23 into 100, that is equal to 2000 plus 300, that is equal to 2300. We are given a table here with 4 columns marked as thousands, hundreds, tens, units. 23 is written under hundreds, and in the next row we have 2 under 1000, 3 under hundreds, 0 under tens and 0 under units place. Similarly, 23 tens would be 23 tens is equal to 23 into 10, that is equal to 200 plus 30, that is equal to 230. Page number 64. Here we have another table with 4 columns in which we have thousands, hundreds, tens and units marked. 23 is written in tens column. And in the next row, we have 2 in hundreds, 3 in tens and 0 in units place. How can we write 234 tenths in decimal form? 234 tenths is equal to 234 upon 10. That is equal to 200 upon 10 plus 30 upon 10 plus 4 upon 10. That is equal to 20 plus 3 plus 4 upon 10. That is equal to 23.4. Here we have another tabular column with 5 columns. First one marked as hundreds, second tens, third units, then we have a decimal place point and then tens and hundredths position marked. We have 234 written under tenths place. Then in the next row we have 2 in tens place, 3 in units place, then decimal point and 4 in tens place. Write these quantities in decimal form. A. 234 hundredths. B. 105 tenths. 3.5. Units of measurement. Length conversion. We have been using a scale to measure length for a few years. We already know that 1 centimeter is equal to 10 millimeters. How many centimeters is 1 millimeter? 1 millimeter is equal to 1 upon 10 centimeters, that is equal to 0.1 centimeters. That is 1/10 of a centimeter. How many centimeters is A. 5 millimeter, B. 12 millimeters. 5 millimeters is equal to 5 upon 10 centimeter, that is equal to 0.5 centimeters. 12 millimeter is equal to 10 millimeter plus 2 millimeters, that is equal to 1 centimeter plus 2 upon 10 centimeter, that is equal to 1.2 centimeter. Page number 65. how many millimeters is 5.6 centimeter? Since each centimeter has 10 millimeter, 5.6 centimeters, that is 5 centimeter plus 0.6 centimeters is 56 millimeters. Fill in the blanks given here in millimeters or centimeters. We have a tabular column here with readings 12 millimeters is equal to 1.2 centimeters, 56 millimeters is equal to 5.6 centimeters, and other 4 boxes are having blanks to be filled up. First one giving 70 millimeters is equal to dash. Next, dash is equal to 0.9 centimeters. 134 millimeters is equal to dash. Dash is equal to 203.6 centimeters. The illustration below shows how small some things are. Try taking an approximate measurement of each. The 3 blue strips represent the typical relative sizes of pen strokes: fine stroke, medium stroke, and bold stroke. Next, a human hair is about 0.1 millimeters in thickness. The thickness of a newspaper can range from 0.05 to 0.08 millimeters. Mustard seeds have the thickness of 1 to 2 millimeters. The smallest ant species discovered so far, Canberra bruni, has a total length of 0.8 to 1 millimeters. They are found in Sri Lanka and China. The smallest land snail species discovered so far, Acmela nana, has a shell diameter of 0.7 millimeters. They are found in Malaysia. We also know that 1 millimeter is equal to 100 centimeters. Based on this, we can say that 1 centimeter is equal to 1 upon 100 meters, that is equal to 0.01 meters. On this page, we are also provided a picture in which we can observe one snail, one small ant, a newspaper, and some seeds. Also, 3 strokes of pens showing the actual size. Page number 66. How many meters is A? 10 centimeters. B. 15 centimeters. 10 centimeter is equal to 1 upon 10 meter or 0.1 meter. Since each centimeter is 1/100th of a meter, 15 centimeter can be written as 15 centimeter is equal to 15 upon 100 meter. That is equal to 10 upon 100 meter plus 5 upon 100 meter. That is equal to 1 upon 10 meter plus 5 upon 100 meter. That is equal to 0.15 meter. Fill in the blanks given below as centimeters or meter. Here we have 6 blanks to be filled up. 36 centimeters is equal to dash meters. 50 centimeters is equal to dash meters. Dash centimeters is equal to 0.89 meters. 4 centimeter is equal to dash meters. 325 centimeters is equal to dash meters. Dash is equal to 2.07 meters. How many millimeters does 1 meter have? Can we write 1 millimeter is equal to 1 upon 1000 meter? Here we have some more interesting facts about small things in nature. On this page, we are provided a picture of a Philippine goby, that is fish, and egg of hummingbird, which is very small in size, and smallest jellyfish, and also an octopus. Page number 67. The egg of a hummingbird typically is 1.3 centimeters long and 0.9 centimeters wide. The Philippine goby is about 0.9 centimeters long. It can be found in the Philippines and other Southeast Asian countries. The smallest known jellyfish, Irukandji, has a bell size of 0.5 to 2.5 centimeters. Its tentacles can be as long as 1 meter. They are found in Australia. Its venom can be fatal to humans. The Wolfie octopus, also known as the star-sucker pygmy octopus, is the smallest known octopus in the world. Their typical size is around 1 to 2.5 centimeters and they weigh less than 1 gram. They are found in the Pacific Ocean. Weight conversion. Let us look at kilograms, that is kg. We know that 1 kg is equal to 1000 gram, within brackets g. We can say that 1 gram is equal to 1 upon 1000 kg, that is equal to 0.001 kg. How many kilograms in 5 grams? 5 grams is equal to 5 upon 1000 kg, that is equal to 0.005 kg. How many kilograms in 10 grams? 10 gram is equal to 10 upon 1000 kg, that is equal to 1 upon 100 kg, that is equal to 0.010 kg. As each gram is 1,000th of a kg, 254 grams can be written as 254 grams is equal to 254 upon 1000 kg, that is equal to 200 upon 1000 plus 50 upon 1000 plus 4 upon 1000 kgs, that is equal to 2 upon 10 plus 5 upon 100 plus 4 upon 1000 kgs, that is equal to 0.254 kg. Fill in the blanks given here in grams or kilograms. Page number 68. Here we have 6 quantities with blanks along the values. 465 grams is equal to dash. 68 grams is equal to dash. 1560 grams is equal to dash. 704 grams is equal to dash. Dash is equal to 0.56 kg. Dash is equal to 2.5 kg. Look at the picture given here representing different quantities of rice. Starting from the 1 gram heap, subsequent heaps can be found that are 10 times heavier than the previous heap or packets. The combined weight of rice in this picture is 11.111 kgs. Here we have in the picture one packet of 10 kg, that is equal to 10,000 grams of rice. Then 1 kg equal to 1000 grams of rice. 0.1 kg, that is equal to 100 grams of rice, and 0.01 kg, that is 10 grams of rice, and 0.001 kg equal to 1 gram rice. Also, 1 gram is equal to 1000 milligrams, that is mg in brackets. So 1 milligram is equal to 1 upon 1000 grams, that is equal to 0.001 grams. Rupee paise conversion. You may have heard of paisa. 100 paise is equal to 1 rupee. As we have coins and notes for rupees, coins for paise were also used commonly until recently. There were coins for 1 paisa, 2 paise, 3 paise, 5 paise, 10 paise, 20 paise, 25 paise and 50 paise. Here on this page we have pictures of all these coins: 50 paise, 25 paise, 20 paise, 10 paise, 5 paise, 3 paise, 2 paise and 1 paise. All denominations of 25 paise and less were removed from use in the year 2011. But we still see paise in bills, account statements, etc. 1 rupee is equal to 100 paise. 1 paisa is equal to 1 upon 100 rupee, that is equal to 0.01 rupee. As each paisa is 1/100th of a rupee, 75 paise is equal to 75 upon 100 rupee. Page number 69. That is equal to 70 upon 100 plus 5 upon 100 rupee. That is equal to 7 upon 100 plus 5 upon 100 rupee. That is equal to 0.75 rupee. Fill in the blanks given here in rupee or paise. 10 paise is equal to dash. Dash paise is equal to 0.05 rupees. Dash paise is equal to 0.36 rupees. Dash paise is equal to 0.50 rupees. 99 paise is equal to dash. 250 paise is equal to dash. During the 1970s, a masala dosa cost just 50 paise. One could buy a banana for 20 to 25 paise. A handful of peppermints were available for 2 paise or 3 paise, and a kg of rice cost 2 rupees 45 paise. There is a beautiful picture of a receipt dated 3rd March 1970, which has descriptions of 3 dosa costing 1 rupee 50 paisa, 2 tea of 12 paisa and 1 cake of 15 paisa. Total 1.77 rupees. Discuss with adults at home or school the prices of different products and services during their childhood. Try to find old coins and stamps. Here on this page, we have pictures of old stamps which has a map of India depicted on them. 3.6 Locating and comparing decimals. Let us consider the decimal number 1.4. It is equal to 1 unit and 4 tenths. This means that the unit between 1 and 2 is divided into 10 equal parts and 4 such parts are taken. Page number 70. Hence, 1.4 lies between 1 and 2. Draw a number line and divide the unit between 1 and 2 into 10 equal parts. Take the fourth part and we have 1.4 on the number line. Here we have a picture of a number line which has 10 parts between 1 and 2 as 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8 and 1.9. Name all the divisions between 1 and 1.1 on the number line. In this picture, we have markings between 1 and 1.1 into 10 equal parts, and the fourth part will represent 1.04. Identify and write the decimal numbers against the letters. Here we have a number line with markings as 5, 5.1, 5.3, 5.4. We also have some markings in red representing alphabets A, B, C and D. You are supposed to identify these decimal numbers. There is zero dilemma. Sonu says that 0.2 can also be written as 0.20, 0.200. Zara thinks that putting zeros on the right side may alter the value of the decimal number. What do you think? We can figure this out by looking at the quantities these numbers represent using place value. Here we have a tabular column with 5 different columns representing decimal number, units, tens, hundreds and thousands place. Decimal number 0.2 is written as 0 in units place, 2 in tens place. 0.20 is written as 0 in units place, 2 in tenths place and 0 in hundredths place. 0.200 is written as 0 in units place, 2 in tenths place, 0 in hundredth place and 0 in thousands place. 0.02 is written as 0 in units place, 0 in tenths place and 2 in hundredths place. 0.002 is written as 0 in units place, 0 in tenths place, 0 in hundredths place and 2 in thousands place. We can notice that 0.2, 0.20 and 0.200 are all equal as they represent the same quantity, that is 2 tenths. But 0.2, 0.02 and 0.002 are different. Page number 71. Can you tell which of these is the smallest and which is the largest? Which of these are the same? 4.5, 4.05, 0.405, 4.050, 4.50, 4.005, 04.50. Observe the number lines in figure A given here. At each level, a particular segment of the number line is magnified to locate the number 4.185. Identify the decimal number in the last number line in figure B denoted by question mark. Here we have two pictures. We have figure 1 in which decimal number 4.185 has been magnified. To begin with, we have markings from 0 to 10, that is 10 equal parts, in which 4 and 5 numbers have been magnified again into 10 equal parts with representation of 4.1 and 4.2, again magnified into 10 equal parts between 4.1 and 4.2. Now we have 4.18 and 4.19 again divided into 10 equal parts. Thus, we have representation of 4.185 on the number line lying between 4.18 and 4.19. Similarly, you are expected to identify the number in figure B using the same magnification process. Make such number lines for the decimal numbers: A 9.876, B 0.407. In the number line given here, what decimal numbers do the boxes labeled A, B and C denote? We have a picture in which we find numbers 5, then A, B, C and 10. We are supposed to identify the numbers in the boxes A, B and C. The box with B corresponds to the decimal number 7.5. Are you able to observe how? There are 5 units between 5 and 10, divided into 10 equal parts. Hence, every 2 divisions make a unit, and so every division is 1/2 unit. What numbers do A and C denote? Page number 72. Using similar reasoning, find out the decimal numbers in the boxes given here. We have markings between 8 and 8.1, and we are provided 2 boxes D and E. We have to find out the decimal numbers of these boxes. Which is larger, 6.456 or 6.465? To answer this, we can use the number line to locate both decimal numbers and show which is larger. This can also be done by comparing the corresponding digits at each place value as we do with whole numbers. This comparison is visualized step by step given here. Note that the visualization is not to scale. We have pictures divided in 3 parts. First for 6456, 6465. Both numbers have 6 units. Next, for 6.456 and 6.465. In this, both numbers have 6 units and 4 tenths. And in the next picture, we have 6.45 and 6.46. Here, both numbers have 6 units and 4 tenths. But the first number has only 5 hundredths, whereas the second number has 6 hundredths. Page number 73. We start by comparing the most significant digits, that is, digits with the highest place value of the 2 numbers. If the digits are the same, we compare the next smaller place value. We keep going till we find a position where the digits are not equal. The number with the larger digit at this position is the greater of the two. Why can we stop comparing at this point? Can we be sure that whatever digits are there after this will not affect our conclusion? Which decimal number is greater? A. 1.23 or 1.32? B. 3.81 or 13.800? C. 1.009 or 1.090? Closest decimals. Consider the decimal numbers 0.9, 1.1, 1.01 and 1.11. Identify the decimal number that is closest to 1. Let us compare the decimal numbers. Arranging these in ascending order, we get 0.9 less than 1, less than 1.01, less than 1.1, less than 1.11. Among the neighbors of 1, 1.01 is 1 upon 100 away from 1, whereas 0.9 is 10 upon 100 away from 1. Therefore, 1.01 is closest to 1. Which of the above is closest to 1.09? Which among these is closest to 4? 3.56, 3.65, 3.099. Which among these is closest to 1? 0.8, 0.69, 1.08. In each case given here, use the digits 4, 1, 8, 2 and 5 exactly once and try to make a decimal number as close as possible to 25. We are provided 3 different situations. In first one, we have 2 boxes, decimal point and 3 boxes after the decimal point. In the next one box before the decimal and 3 boxes after the decimal. In the next one, we have 3 boxes before the decimal point and 2 boxes after the decimal point. Page number 74. 3.7. Addition and subtraction of decimals. Priya requires 2.7 meters of cloth for her skirt and Shailaja requires 3.5 meters for her kurti. What is the total quantity of cloth needed? We have to find the sum of 2.7 meters plus 3.5 meters. Earlier, we saw how to add 2 whole 7 upon 10 plus 3 whole 5 upon 10. Also given here, can you carry out the same addition using decimal notation? It is given below. Share your observations. The total quantity of cloth needed is 6.2 meters. 2 whole 7 upon 10 plus 3 whole 5 upon 10 when added is equal to 5 whole 12 upon 10, which can be written as 6 whole 2 upon 10. The other way of doing is 2.7 plus 3.5 when added gives us 6.2. How much longer is Shailaja's cloth compared to Priya's? We have to find the difference of 3.5 meters minus 2.7 meters. Again, observe how the difference is 3 whole 5 upon 10 minus 2 whole 7 upon 10 and 3.5 meters minus 2.7 meters are computed. 3 whole 5 upon 10 minus 2 whole 7 upon 10 can be expressed as 2 whole 15 upon 10 minus 2 whole 7 upon 10, which on subtraction gives us 0 whole 8 upon 10. Or it can be done the other way, 3.5 minus 2.7 is equal to 3.5 minus 2.7, which gives us 0.8 on subtraction. As you can see, the standard procedure for adding and subtracting whole numbers can be used to add and subtract decimals. A detailed view of the underlying place value calculation is given here for the sum 75.345 plus 86.691. Its compact form is given on the next page. Page number 75. The place value calculation for the addition of 75.345 and 86.691 is given here in detail. 75.345 plus 86.691 on addition gives us 162.036, which has been explained with the help of the figure and calculations. Write the detailed place value computation for 84.691 minus 77.345 and its compact form. Figure it out. First, find the sums. A. 5.3 plus 2.6. B. 18 plus 8.8. C. 2.15 plus 5.26. D. 9.01 plus 9.10. E. 29.19 plus 9.91. F. 0.934 plus 0.6. G. 0.75 plus 0.03. H. 6.236 plus 0.487. Second, find the differences. A. 5.6 minus 2.3. B. 18 minus 8.8. C. 10.4 minus 4.5. D. 17 minus 16.198. E. 17 minus 0.05. F. 34.505 minus 18.1. G. 9.9 minus 9.09. H. 6.236 minus 0.487. Decimal sequences. Observe the sequence of decimal numbers and identify the change after each term. 4.4, 4.8, 5.2, 5.6, 6.0, and so on. We can find that 0.4 is being added to a term to get the next term. Continue this sequence and write the next three terms. Page number 76. Similarly, identify the change and write the next three terms for each sequence given here. Try to do this computation mentally. A. 4.4, 4.45, 4.5, dash. B. 25.75, 26.25, 26.75, dash. C. 10.56, 10.67, 10.78, dash. D. 13.5, 16, 18.5, dash. E. 8.5, 9.4, 10.3, dash. F. 5, 4.95, 4.90, dash. G. 12.45, 11.95, 11.45, dash. H. 36.5, 33, 29.5, dash. Make your own sequences and challenge your classmates to extend the pattern. Estimating sums and differences. Sonu has observed sums and differences of decimal numbers and says, if we add two decimal numbers, then the sum will always be greater than the sum of their whole number parts. Also, the sum will always be less than 2 more than the sum of their whole number parts. Let us use an example to understand what his claim means. If the two numbers to be added are 25.936 and 8.202, the claim is that their sum will be greater than 25 plus 8, that is whole number parts, and will be less than 25 plus 1 plus 8 plus 1. What do you think about this claim? Verify if this is true for these numbers. Will it work for any two decimal numbers? What about for the sum of 25.93603259 and 8.202? Similarly, come up with a way to narrow down the range of whole numbers within which the difference of two decimal numbers will lie. Note to the teacher: estimating the result before computing may help in identifying if a mistake happens with the calculation. 3.8 More on the decimal system. Decimal and measurement disasters. Decimal point and unit conversion mistakes may seem minor sometimes, but they can lead to serious problems. Here are some actual instances in which such errors caused major issues. Page number 77. In 2013, the Finance Office of Amsterdam City Council, that is Netherlands, mistakenly sent out 188 euro million in housing benefits instead of the intended 1.8 euro million due to a programming error that processed payments in euro cents instead of euros. 1 euro cent is equal to 1 upon 100 euro. In 1983, a decimal error nearly caused a disaster for an Air Canada Boeing 767. The ground staff miscalculated the fuel, loading 22,300 pounds instead of kilograms, about half of what was needed. That is, 1 pound is approximately equal to 0.453 kgs. The plane ran out of fuel mid-air, forcing the pilots to make an emergency landing at an abandoned airfield. Fortunately, everyone survived. Several instances have occurred due to incorrect reading of decimal numbers while giving medication. For example, reading 0.05 milligrams as 0.5 milligrams can lead to using a medicine 10 times more than the prescribed quantity. It is therefore important to pay attention to units and the location of the decimal point. Deceptive decimal notation. Saryu gets a message. The bus will reach the station 4.5 hours post noon. When will the bus reach the station? 4:05 p.m., 4:50 p.m., 4:25 p.m. None of these. Here, 0.5 hours means splitting an hour into 10 equal parts and taking 5 parts out of it. Each part will be 6 minutes, that is 60 minutes upon 10 long. 5 such parts make 30 minutes, so the bus will reach the station at 4:30. Here is a short story of a decimal mishap. A girl measures the width of an opening as 2 feet 5 inches but conveys to the carpenter to make a door 2.5 feet wide. The carpenter makes a door of width 2 feet 6 inches. Since 1 feet is equal to 12 inches, 0.5 feet is equal to 6 inches, and it wouldn't close fully. We have a picture of Sarayu and carpenter which explains the same situation. Page number 78. If you watch cricket, you might have noticed decimal looking numbers like overs left 5.5. Does this mean 5 overs and 5 balls or 5 overs and 3 balls? Here 5.5 overs means 5 whole 5 upon 6 overs, as 1 over is equal to 6 balls, that is 5 overs and 5 balls. Where else can we see such non-decimals with a decimal-like notation? A pinch of history, decimal notation over time. Decimal fractions, that is, fractions with denominators like 1 upon 10, 1 upon 100, 1 upon 1000, and so on, are used in the works of a number of ancient Indian astronomers and mathematicians, including in the important 8th century works of Sridharacharya on arithmetic and algebra. Decimal notation in essentially its modern form was described in detail in Kitab al-Fizul fi al-Hisab al-Hindi, the book of chapters on Indian arithmetic by Abul Hasan al-Uklidishi, an Arab mathematician in around 950 CE. He represented the number 0.059375 as 0059375. In the 15th century, to separate whole numbers from fractional parts, a number of different notations were used. A vertical mark on the last digit of the whole number part, as displayed here, use of different colors, and a numerical superscript giving the number of fractional decimal places. Within brackets, 0.36 would be written as 36 with a 2 upon 6, close the bracket. In the 16th century, John Napier, a Scottish mathematician, and Christopher Clavius, a German mathematician, used the point or period decimal point to separate the whole number and the fractional parts, while Francois Vitti, a French mathematician, used the comma instead. Currently, several countries use the comma to separate the integer part and the fractional part. In these countries, the number 1,000.5 is written as 1000,5. Space as a thousand separator, but the decimal point has endured as the most popular notation for writing numbers having fractional parts in the Indian place value system. Figure it out. First, convert the following fractions into decimals. A. 5 upon 100. B. 16 upon 1000. C. 12 upon 10. D. 254 upon 1000. Page number 79. Question number 2. Convert the following decimals into a sum of tenths, hundreds and thousands. A. 0.34. B. 1.02. C. 0.8. D. 0.362. Question number 3. What decimal number does each letter represent in the number line below? We have a picture of a number line having marks on it as 6.4, A, 6.5, C, B, and 6.6. We are supposed to write down the decimal numbers in each letter A, B, and C. Question number 4. Arrange the following quantities in descending order. A. 11.01, 1.011, 1.101, 11.10, 1.01. B. 2.567, 2.675, 2.768, 2.499, 2.698. C. 4.678 grams, 4.595 grams, 4.600 grams, 4.656 grams, 4.666 grams. D. 33.13 meters, 33.31 meters, 33.133 meters, 33.331 meters, 33.313 meters. Question number 5. Using the digits 1, 4, 0, 8 and 6 make A. the decimal number closest to 30. B. the smallest possible decimal number between 100 and 1000. Question number 6. Will a decimal number with more digits be greater than a decimal number with fewer digits? Question number 7. Mahi purchases 0.25 kg of beans, 0.3 kg of carrots, 0.5 kg of potatoes, 0.2 kg of capsicums, and 0.05 kg of ginger. Calculate the total weight of the items she bought. Question number 8. Pintu supplies 3.79 liters, 4.2 liters, and 4.25 liters of milk to a milk dairy in the first 3 days. In 6 days, he supplies 25 liters of milk. Find the total quantity of milk supplied to the dairy in the last 3 days. Question number 9. Tinku weighed 35.75 kg in January and 34.50 kg in February. Has he gained or lost weight? How much is the change? Question number 10. Extend the pattern 5.5, 6.4, 6.39, 7.29, 7.28, 6.18, 6.17, dash. Question number 11. How many millimeters make 1 kilometer? Question number 12. Indian Railways offers optional travel insurance for passengers who book e-tickets. It costs 45 paisa per passenger. If 1 lakh people opt for insurance in a day, what is the total insurance fee paid? Question number 13. Which is greater? A. 10 upon 1000 or 1 upon 10? Page number 80. B. 100th or 90 thousandths? C. 1000th or 90 hundredths? Question number 14. Write the decimal forms of the quantities mentioned. An example is given. A. 87 ones, 5 tenths and 60 hundredths is equal to 88.10. B. 12 tenths and 12 tenths. C. 10 tenths, 10 ones, 10 tenths and 10 hundredths. D. 25 tenths, 25 ones, 25 tenths and 25 hundredths. Question number 15. Using each digit 0 to 9 not more than once. Fill the boxes given here so that the sum is closest to 10.5. We have 1 box before the decimal point and 3 boxes after the decimal point. Plus, in the second row again, we have 1 box before the decimal point and 3 boxes after the decimal point. We are supposed to fill up the digits in these boxes so that the sum is closest to 10.5. Question number 16. Write the following fractions in decimal form. A. 1 upon 2. B. 3 upon 2. C. 1 upon 4. D. 3 upon 4. E. 1 upon 5. F. 4 upon 5. Summary. We can split a unit into small parts to get more exact or accurate measurements. Second, we extended the Indian place value system and saw that 1 unit is equal to 10 1/10ths. 1/10th is equal to 10 100ths. 100th is equal to 10 1000ths. 10 100ths is equal to 1/10ths. 100 100ths is equal to 1 unit. Next, a decimal point dot is used in the Indian place value system to separate the whole number part of a number from its fractional part. Next point, we also learnt how to compare decimal numbers, locate them on the number line and perform addition and subtraction on them. Chapter number 3 ends here.
Ganit Prakash, you were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration, Swarnlata Sharma. Sound recordist, Prasoon Kumar. Production assistant, Soumya Malik. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.